So you're new to Kubernetes and you want to learn how to use it. You want to run it locally for testing. You want to learn how to browse Kubernetes and how to troubleshoot it, which will ultimately help you understand how it works. Now you can go ahead and use a fancy UI or a dashboard, but the native way to use Kubernetes is with the command line. Now a lot of people can find this slightly challenging. The command line can be quite daunting to some people, and Kubernetes adds a bunch of complexity on top of that, which makes it a bit overwhelming. In this video, you can sit back, relax, as we are about to demystify it, so you can get started and get comfortable with all the commands. In this video, we're going to be taking a step back and look at kubectl. We're going to spin up a Kubernetes cluster, we're going to learn how to access clusters, browse them, and interact with them. And once you walk away from this video, you should be comfortable with the command line. So without further ado, don't be scared, and let's go. So if we take a look at my GitHub repo, I have a Kubernetes folder, and in the Kubernetes folder I have a kubectl folder with a readme, and this is our introduction to kubectl. This is going to show you how to download kubectl. We're going to use a utility called kind to spin up a Kubernetes cluster locally, and we're going to take a look at all the different kubectl commands and how to work with Kubernetes. So be sure to check out the link down below to the source code so you can follow along. Now the first thing we're going to do is go ahead and download kubectl. Now you can use any of your favorite methods to do this, but the important thing to learn here is that we need to know which version of kubectl to download. You will always want the same or slightly higher version of kubectl than the cluster you're going to manage. So if you're running a 1.24 Kubernetes cluster, you'll want kubectl 1.24 or higher, and it's pretty backwards compatible. So if you have a slightly older version of Kubernetes, you should be able to manage that with a higher version of kubectl with little to no issues. So it's best to keep your version of kubectl updated. So to download kubectl, we can follow the link to the official docs, and this is the official Kubernetes website. They have an install tools section which shows you how to download and install kubectl. You can go ahead and select the version you like and download the executable. If you're installing kubectl on Linux, there's a few ways. You can download the binary using curl, or you can use the native package management. Once you have the binary, you can simply move it to user local bin. If you want to set it up on Windows, it's pretty similar. You can use curl to download the kubectl exe, or you can use chocolate to your PowerShell. So you can see it's as simple as running a curl command and downloading the kubectl version. Have a look in the URL, you can also see the version of kubectl, so you can go ahead and change this to match the version you want to download. I've created a folder under my local C drive called kubectl, and I've just put all my utilities in here that I download. You can see I have kind and I have kubectl in here, and then you should be pretty familiar to map this folder to your path environment variables. So if you're running on Windows, you go to system properties, you open up environment variables, you look at your path, and you can see I've added that directory to my path environment variable. Once you have it in your path on Windows, or if you're running Linux and you have it on your user local bin, you open up a new terminal and you just run kubectl version, and you should see the output being printed. So you can see the client version is 1.24. This is the version that I downloaded. The kubectl version command is important to understand which version of kubectl you're running. And if you have kubectl configured to look at a Kubernetes cluster, it'll tell you the version of that cluster as well. But we'll take a look at that in a minute. Kubectl has a configuration file which is used to tell kubectl where your Kubernetes cluster is. Now the default location where kubectl looks for a Kubernetes config is in the user directory under a .kube folder, and it looks for a file called config by default, but this can all be changed. You can tell kubectl to look elsewhere, and you can also tell it to look elsewhere with a single command. So in Linux and Windows, it'll be located under your users directory in a folder called .kube, and there'll be a configuration file called .config. Now what I'm going to do, I'm going to start from scratch. So I'm going to go ahead and delete this config. Now, when you deploy a new cluster, whether it be on your local or in the cloud, or you simply access a Kubernetes cluster, you may notice that this config file may be automatically generated if it doesn't exist, or it may be automatically updated. For example, in Microsoft Azure, you'll use the Azure CLI to grab a Kubernetes config file to access your AKS. Now, Google and Amazon and other Kubernetes distributions have a similar method to get the Kubernetes config. Even if you're running on-prem, you may have Kubernetes configs for your on-prem clusters that you need to share with the users. Now, the first thing we need to continue is a Kubernetes cluster, and for this I'd like to introduce you to a lightweight utility called Kind. Now, you can use something like Minikube as well, but Minikube is quite heavy because it uses a virtual machine. Kind uses Docker containers to run Kubernetes clusters, so they're very lightweight. They're extremely fast. They start up really quick, and you can run multiple Kubernetes clusters, and if you make a mistake you can just delete the cluster and start again. And on top of that, we can run a lot of clusters locally for different projects and simply throw them away when we're done. Now, if we go back to the Kubernetes official page where we looked at installing tools like kubectl, you can see if you scroll down there is also a reference to Kind and a quick start guide which takes you to the Kind website. And if we take a look at the installation, it tells you how to install this. So what I've done is gone to the top right corner and access the GitHub link. This will take you to the Kind GitHub repo. You can go down to the releases page, and here you can see every version of Kind, and all you need to do is pick the version that you want, scroll down to the binaries, and here you can see you can have the Kind executable for Linux as well as Windows. So I've gone ahead and downloaded this executable. I've renamed it to kind.exe. In Linux it'll just be Kind without the extension, and I've added it to the folder which already exists on my path. Once I have that, I can say Kind, and now I have Kind installed. You can see all the commands are listed and ready to go. And if we go back to my README, I've documented to show you how easy it is to create a lightweight Kubernetes cluster. So all I need to do is say Kind create cluster, I give the cluster a name, and I tell it what image to use for my Kubernetes cluster. So I pick the version of Kubernetes, and in this version I'm going to run 1.23.5. so this is the version of Kubernetes I want to run. You can also pass it a YAML file to tell it to run multiple worker nodes, so you can run larger clusters for testing purposes. So what I'm going to do is I'm going to run this command in the terminal, and that will go ahead and spin up a Kubernetes cluster called dev. And if we wait a few seconds, we can see it's now been created. Now, how quick and easy was that? And if I need a second cluster, I can just run another Kind command. So I can say Kind create cluster. This time I'm going to call it prod, and I'm going to create the same version of Kubernetes. So I go ahead and run this in the terminal, and that'll spin up a second Kubernetes cluster. And with Docker, I can say Docker PS, and we can see the two Kubernetes nodes that are running. One is my dev cluster, the other one is my prod cluster. Now, every time I spin up a Kubernetes cluster, Kind will go ahead and update my kubeconfig file locally, and it will update whichever one I'm currently pointing to, which is the default one. Minikube also does this. When you spin up a Minikube cluster, it'll update your kubeconfig file. If you're running Kubernetes on Google, you'll have to run the gcloud command to access your cluster. If you're running on EKS, there is an EKS command equivalent, as well as AKS. Other cloud providers have their commands as well, or you can just download the kubeconfig from the website portal for your cloud provider. Now, with the clusters created, let's see what Kind did with our kubeconfig file. So if we take a look at the default location where the kubeconfig file is, you can see that it created a config file now. If I go ahead and drop this in VS Code, we can take a look at it. And what we can do is collapse all these entries, and we see that the kubeconfig file is very simple. We have a list of clusters, we have a list of contexts, and we have a list of users. And then we have something called current context. Now, clusters is very simple. If I expand one of the clusters, you can see it's simply the location of the master nodes. So every time we run kubectl commands, these commands will go to the master node and be executed. So we can see here we have one cluster called Kind dev, and then we have another entry here for Kind prod. If you're accessing AKS, GKE, or cloud-based clusters, the entries will be alongside here. If you decide to use one big kubeconfig file, I'll show you how to split this up in a minute. The next one we want to look at is users. Kubernetes doesn't have a concept of users, so in this case, what a user is simply a way to authenticate with a cluster. If we take a look at the users, we can see we have two users listed here, one for our our kind cluster for dev and one for our kind cluster for prod. And all that this contains is a certificate data, because Kubernetes by default uses certificate authentication, and it basically passes this to the Kubernetes control plane, to the master nodes, and they decide if we can have access or not. Now there are other authentication plugins for Kubernetes. So if you're accessing an Azure Kubernetes cluster which is joined with Active Directory, or you're using EKS where you may be using your Amazon account to sign in, you may see like OAuth details under the user section. So it may have some token data on how to authenticate with an OAuth authentication, and potentially some links to an OAuth server or an Active Directory server. So clusters is about where the cluster is, users is about how to authenticate with that cluster, and next up we have context. Now context is the thing that binds the user and the cluster together. So you can see our current context is kind prod. So this tells kubectl that whenever it looks at this config, that it has to access the prod cluster by using the prod context. So what it will do is kubectl will see, okay, I need to use the prod context. It'll go to the context and find the prod. So this is the dev one, so it won't use this. It will use this context over here, which is the production context. So by looking at this, it will know which cluster to use. So it will go to the cluster section and grab the prod cluster details. So it will know to connect to this server. And it knows which user to use because that's listed under the context as the user. So then it'll go down to the user section and grab that user data and authenticate. So that is in a nutshell how kubectl finds the cluster and authenticates with it. And as I mentioned, Kubernetes doesn't have the concept of users. So by default, it'll use certificate data to authenticate as a user. And if you're accessing a cloud provider, you may see OAuth details in the user section. Now you can also check all of this out using the command line. So the first command I want you to run is kubectl config. When you run this, it'll give you all the available subcommands you can run. Now there's going to be three main commands we want to run. The current context, that tells us where we are currently looking at, so we don't accidentally run kubectl commands against the wrong cluster. There's get context, so we can see the list of clusters that we have access to. And there is set context, so we can set the context of the cluster we want to point to. So after running kubectl config, the first subcommand we want to take a look at is kubectl config current context. That'll tell us that we are currently accessing the prod context. Then next up, there is a kubectl config get context. That'll tell us all the context that exist in our kubeconfig file. If I run that, that'll show us that we have a dev cluster and a prod cluster access. And it will have a little star next to the one that's the current one. So any command we currently run will run against our prod cluster. And then the final subcommand we want to take a look at is the use context command. So we say kubectl config use context, and we use this command to change the context. So let's say currently I'm accessing the prod cluster, but I want to run commands against the dev cluster. So I'll take the dev context name and paste it there. So I'll say kubectl config use context and the name of the dev context. Now we can see we have successfully switched the context. So if I run kubectl config current context again, we can see we're now pointing against the dev cluster. Now you see the first problem here is that this kubeconfig file can get pretty large. Now you can either manage all of this in one kubeconfig by keep switching context, or you can split your kubeconfigs up into separate files, which is a better way to do things. So you can have a file for your dev clusters, you can have a file for production clusters, and you can even have a separate file for local clusters. This will prevent you from accidentally running kubectl commands against production clusters. So now we have an understanding of the kubeconfig, and just so you know, I've recorded all the commands in this readme file, so you can go ahead and try them out yourself alongside watching the video. Now there are a few ways to split configs. For cloud providers it's pretty simple, because every time you access a cloud provider cluster, it allows you to download a kubeconfig file, and it also allows you to merge that cluster config with your current kubeconfig file. Now the easiest way is just keeping all the these files separate. If your cloud provider is merging with your config, it'll generally merge with your default kubeconfig, and we can override this path by using the kubeconfig environment variable. So you can see on Linux we can set this using the export command, so we can set a kubeconfig variable to a different path, and on Windows we can do this similarly by setting a kubeconfig variable to a different directory. Now, similarly to cloud clusters, when accessing a kubeconfig file, we can also tell the cloud provider to download the kubeconfig to a different file. So we can tell Azure CLI or EKS CLI that we want to download the Kubernetes config to a different file. So we can manage our dev and prod clusters separately. Similar to kind, we can also do this by saying kind, the name of our cluster. We can run the export command, and we can say we want to export a kubeconfig, and then we pass in a flag which tells it where to export that kubeconfig to. So you can see I say kubeconfig and I download it to my default location where my kubeconfigs exist, but this time instead of using the default name config, I give it a separate name, so I call it devconfig. So I'm going to go ahead and run this command, paste that to the terminal, and then I'm going to do the same for prod. I'm going to copy this, paste it to the terminal. You can do this for your cloud provider clusters as well. Now if we take a look at the file system, we have our default config file which has all the clusters merged, and then we have separate ones, one for dev, one for prod. And then what I can do to keep it safe, I can go ahead and delete my local kubeconfig file. So if we do kubectl get nodes or run any kubectl command against our cluster, we'll see that we'll get an error because the default config file is not found. And then what we can do is we can go ahead and set the kubeconfig variable to tell it which config to access. So I can go ahead and run this, and I can say I want to run commands against my prod config, and if I do kubectl get nodes now, you can see kubectl now knows where to look. So we override the default location of where it will look for accessing a Kubernetes cluster, and this environment variable is only bound to this terminal. So if I go ahead and open up another terminal and I run kubectl get nodes, you can see it will not find that because it's going to look again at the default location. So what this means is I can access all my local clusters in my default location config, and my cloud-based clusters, I can put them in separate kubeconfig files, so I don't accidentally run commands against the cloud-based clusters. If I want to access production, I explicitly have to write this command to say I want to access production. So that is essentially how you split Kubernetes configs into separate files. So now that we understand kubeconfigs and we have our access to our clusters sorted, the next step is to learn how to work with Kubernetes resources and what commands are important. Now the commands that you will use the most is get, create, apply, and describe. Get is to simply fetch resources, describe tells you a little bit more about the resource, create is to create a brand new resource, and apply is to apply any changes. But first we'll need to understand namespace. A namespace is a way to group multiple resources together. Now you can go ahead and create a new namespace per project that you're doing, but what you'll find is that you'll end up with a lot of namespaces, which becomes unmanageable. So generally it's a best practice to create a namespace per team or per department, because it's generally more about governing the security and the access to resources. Kubernetes has role-based access control, so you can give a specific team access to specific namespace only. So you use namespaces to scope security, so certain teams can only access certain namespaces. So the first command we look at is the get command. You can run kubectl get and then the type of resource. So what we want to do is get a list of all the namespaces. So I'm going to say kubectl get namespaces, and you can see that Kubernetes comes with a few namespaces, a few system-based ones, and a default one. We can also use the get command to get other types of resources, and the main ones you'll be working with are pods, deployments, services, config maps, secrets, and ingresses. I've made a video on each of those types of resources, so if you want to learn about them, check the link down below. Now that covers the get command. The next command we'll take a look at is the create command, which allows us to create Kubernetes resources. Now the next command we'll take a look at is the kubectl create command to understand how to create resources. It's important to understand that, but it is also important to understand that Kubernetes is a declarative system. So we're not meant to be writing a lot of kubectl lines to create resources. It's okay to create a secret or create a config from from a local file, but generally in the future for maintaining and managing these resources, you'll want to do it declaratively with a YAML file. We'll take a look at that in a minute. And then you may use tools like Kustomize or Helm to maintain multiple YAML files as packages. But let's take this step by step. And it's important when working with the command line to learn how to use the help flag. So you can see I said kubectl create -- help, because the help command will tell you all the available sub commands, so what type of resources you can create, and it also gives you some good useful examples. So if you get stuck with the command or you're having some syntax error, you can generally refer to the help flag and look at the help that gets printed out to guide you in the right direction. Now you can see when taking a look at the help here, we have available sub commands. So we can say kubectl create cluster role, binding, config map. These are all the resources we can create from the create command. Now we can actually set up a full working infrastructure just using the create command. So let's play around with that. I've listed a couple of commands we can run. The first one is create ns, which stands for namespace. So you can say kubectl create namespace, or the short version, which is ns. And I'm going to create one called example apps. So I go ahead and run that. And if I say kubectl get namespaces, we can see our namespace is now listed. Now I can go ahead and create resources in this namespace. And the way to do that is to run kubectl commands and pass the namespace flag, which is -n. So any kubectl command that I run will by default run against the default namespace. So if I do kubectl create, it'll create resources in the default namespace unless I specify a namespace. And most kubectl commands will be able to specify a namespace. If I say kubectl in the example apps namespace, create deployment. So we say create followed by the type of resource and then the name of the resource. So I say create deployment, and I want to call this deployment web server, and then just a bunch of flags. Now the deployment resource takes in things like an image, which is the Docker image we want to deploy. I'm just going to deploy Nginx in this example. It takes in port, and it also takes a bunch of other flags. If you want to see those, simply take the create command. So say kubectl create deployment and say -- help. And this will print out a bunch of examples. So let's go ahead and run that. So I say paste, and that will go ahead and create a new deployment called web server. I can then use the get command to get that deployment. So I say kubectl in the example apps namespace get deploy, go ahead and run that. You can see we have 0 out of 1 pod. That is because the pod is not ready, it's still creating. I can view the pod by saying kubectl get pods, go ahead and run that, and we can see now it's up and running. So it's 1 out of 1. If I do get deploy again, we can see it's now ready. So it's showing 1 out of 1 pod is running. If you want to learn more about deployments, check out my link down below to my Kubernetes deployment guide. So that is the create command for creating a deployment resource. The next one we can do is we can actually go ahead and expose that deployment using a Kubernetes service. Kubernetes services is what's used to expose pods. We use it to set up the networking so that we can expose our application. Remember, the IP address of your application instance can change. If you have 5 pods, you'll have 5 different IPs. If you want to load balance traffic to these pods, you'll use what's called the Kubernetes service. Services can expose your applications privately as well as publicly. If you want to learn more about Kubernetes service, check the link down below. I'm going to go ahead and create a Kubernetes service by saying kubectl in the example apps namespace create service. So instead of saying create deployment, I now say create service. Then I pass in sub commands which is specific to the Kubernetes service. So a service accepts a bunch of things. So if we say create service -- help, the available commands is we can create a cluster IP service. This is a private Kubernetes service. We can create an external name type service. We can create a load balancer service and a node port service. Generally what we do in Kubernetes is we expose all our applications privately, and then we use something called an ingress to expose it publicly. We'll take a look at that in a minute. But for now, what we're going to do is we're going to go ahead and create this service. So we say create service cluster IP for a private service. We're going to call this service web server since it's going to expose our deployment called web server. So I like to keep the names the same. And And then all I say is the port that I want to expose, which is port 80. I go ahead and run that, and now we have a Kubernetes service. I can then run the get command to get the service resource. Go ahead and run that. We can see we have a web server now running. It doesn't have an external IP because it's a private service. That's the IP internally we can reach it on, and it's exposing port 80. Now, just another little tip, which is a more advanced use of kubectl, we can also access pods and services over the port that they're accessing by using the Kubernetes port forward command. It actually sets up a little proxy tunnel from your kubectl and binds it to localhost, so you can access pods even if they are running privately. So to do that, I say kubectl again. I specify the example app namespace and I call the port forward command, and this takes in the type of resource that you want to port forward to, and then you have to say slash and the name of the resource. So I say svc for service and slash and the name of the service. And then I want to port forward port 80. So this is going to bind my local port 80 with the port 80 in that service. So I run that and see what it's doing. It's forwarding all my local port 80 ports to the actual Kubernetes service on port 80. I can go to my browser on localhost and we can see we're now accessing Nginx in our Kubernetes cluster. So that's the port forward command. Now, the next two type of resources you'll probably come across more often is config maps and secrets. A config map is basically application configuration. So any kind of config files that you use to run your application. Generally, when running locally in Docker, you would mount these as a Docker volume. In Kubernetes, this is also done as a volume, but to store these configs, we use what's called a config map. Secrets is almost identical. The only difference is a secret is used to house sensitive data. And the reason why we have config maps and secrets separately is so that we can set up RBAC, so we can secure secrets, because config files may not need the same type of security. The other reason is Kubernetes can be configured to encrypt secrets at rest. So that's why those resources are separate. Now you can use the kubectl create command to create config maps and secrets by referring to local config or local secret files. If you have SSL certificates, you might create a secret by referring to the local certificate, and that'll create the resource in the cluster. So if we take a look at my GitHub repo, I have a Kubernetes folder, and then I have the kubectl folder with the readme where our guide is. And in the kubectl folder, I have a JSON file for our config. So this is our application configuration file. You can see it's a simple example file, just saying config and some config value, and this represents our application config. I can also have a secret.json, which might have more sensitive details, which is like a sensitive configuration, or a TLS certificate, or some API keys, or what have you. Now, to create these as config maps and secret, we use the kubectl create command, and we specifically say we want to create a config map. The same way we do a secret, we say create secret, and there are different types of secrets. So in this case, we're going to use the generic type. So we say we want to create a generic secret, and then the name of the resource. So the name of the secret, in this case, I'm going to call it web server-secret, and my config map is going to be created by calling it web server-config. And then both of these create commands take in a flag which is called from file. So we can create secrets and configs from local files. So in the config map, I'm actually going to call this resource config.json. So when we look at the config map, we'll see inside a resource called config.json. That means you can actually rename that resource if you want. And then I'm going to map config.json to this local config that we just taken a look at, which is under Kubernetes kubectl config, the path on the left. The same way I'm going to do it with the secret. I'm going to say -- from file. I'm going to call it secret.json, and I'm going to map to the local file. So this allows you to have a different file name locally and a different name of the file in the actual secret or config map. When a deployment actually uses the secret or config map, it'll see this file name on the left. So let's go ahead and run that. So I say kubectl in the example apps namespace, create my config map called web server config from the file, and I want to call the file in the config map config.json, and that's the config I want to reference. Go ahead and run that. That'll create a config map. I can then view the config map by saying get cm. Cm is short for config map, and we can see it's been created. So there it is right there. The same way I can create a secret. So in the example apps namespace, I create a generic secret called web server secret from file, and I want to create it from the secret.json file. Go ahead and run that. That'll create that secret, and the same way I can use the get command to list the secret. So I go ahead and run that, and we can see there is our secret. So now we've gone ahead and created a bunch of resources using the kubectl create command. Now, although you might be using the create command fairly frequently, it's generally preferred in Kubernetes to create resources declaratively using a YAML file. When using YAML files, you can actually record those in GitHub. So rather than listing out all the commands someone needs to run, all they need to do is apply the YAML file. So all of the resources we've just created, we can actually export as YAML files. Now, the cool thing with kubectl is that you can go ahead and export existing resources as YAML files as well. And you may find that there's other tools available for creating these YAML files. We can also refer to the Kubernetes document and craft the YAML files from scratch. But before we do any of this, just a quick word from our sponsor who made this video possible. Now, the problem with dealing with Kubernetes YAML is that it can become increasingly complex to manage. When you think of YAML, you think of hundreds of files, thousands of lines, complex Helm charts, and customized templates. Now, two main things come to mind here: human errors and misconfiguration. Now, thankfully, there is a free and magical open source utility that helps us solve these challenges, and it's called Datree. Datree is a tiny command line app that helps us test our YAML files. It checks our YAML for broken YAML syntax, for valid Kubernetes schema, and also helps enforce and checks policies, and also helps manage these policies from a dashboard. You can even run Datree in your GitHub Action pipeline and prevent your precious pipeline from running if any YAML misconfiguration or policy issues are detected, as Datree supports multiple CI/CD workflows. Datree also ships in the form of a Kubernetes webhook, which can run Datree every time resources are applied to your cluster. This means Datree can run at every stage of our software delivery workflow. It can run checks locally, in our CI pipeline, during deployments, and also run against resources that are already deployed, end to end. Datree also supports Helm, has native customized support, lots of official integrations, as well as community plugins like VS Code. Now, today's video is proudly sponsored by Datree. Check out the link down below for my full Datree tutorial. So as I mentioned, it's best to create resources declaratively using YAML files. And what Kubernetes expects you to do is follow the documentation. So if you want to create a deployment, you'd come to the document, look at deployment, and they basically tell you how to create a deployment. So you generally come here, grab the YAML from here, and then use the Kubernetes API documentation to understand each of these fields and maybe add fields or remove fields and do the changes. So the YAML file describes the resource completely. So like a deployment will tell you exactly the name of the deployment, the labels you want on it, how many replicas you want to run. It'll tell you things like the container specification, so the name of the container and the image you want to use, as well as the ports you want to expose for that container. And there are a lot of other fields for deployments as well. The same thing goes for things like config maps. It'll tell you all about the config map, how to write that as a YAML file, and the same thing for services and all the other types of Kubernetes resources. Now, since this video is about kubectl, I want to show you that kubectl can also export existing resources as YAML files. This can be very useful at some point. So what I'm going to do is write a few kubectl commands. I'm going to say kubectl in the example app namespace, and I'm just going to use the get command. So all of these are the get commands. I'm going to say get config map. I'm going to get my config map back. Now, generally when I run this command, it'll just return the resource, right? All of these commands will return the resource, but what I can do is kubectl has the -o flag, which stands for output. We can change the output that we want to return. So if I did this and passed -o YAML, it'll return the YAML for that resource. I can also change that and say I want JSON output, and it'll return the JSON format of the output. And then what I'm going to do is I'm just going to pipe that output into a local file. So on the left here, I've created a folder called YAML. And what I'm going to do is I'm going to output all the resources as YAML files, and I'm going to output them to this YAML folder. So I'm going to output my config map as config.yaml. I'm going to have my secret as secret.yaml, deployment.yaml, and service as service.yaml. So quickly go ahead and run all of these commands. So now I've run all of them, and you can see here now we have our YAML files on the left here. So now we have all the declarative YAML for our entire infrastructure that we've just created. Now it'll take some time for you when you're new to Kubernetes to actually learn all these fields and what they all mean. And what you'll learn is that kubectl output as YAML might write a whole bunch of fields that you don't really need if you're going to be using this YAML in the future. Like you see on my deployment resource, it actually has the status field as well. So it has a whole bunch of status details that I don't need. So I'm going to go ahead and remove that. It also has things like the scheduler, which I don't need. It has things like UID resource version, which I don't need. It has the creation timestamp as well as the revision, which I also don't need. So I'm just going to go ahead and clean that up. So this is my deployment.yaml. If I take a look at my config map, it also has UID and resource version, which I don't technically need. I don't need the creation timestamp. So that's my config map. We take a look at secret, has UID and resource version. I'm going to remove those and the timestamp as well. And my Kubernetes service, it has a status, which I'm going to remove. I don't need that. It has cluster IPs. I don't need those. I don't need the actual value because that value might change. I'm going to remove the UID and resource version and the create timestamp as well. So now I have all my declarative infrastructure configuration as YAML, which I can go ahead and commit to Git. Just make sure when dealing with YAML files and dealing with Git is that you don't end up submitting any sensitive data to Git. So things like secrets is something we generally don't commit to Git. So now you can actually package these YAML files together and create something called a Helm chart or a customized template if you wish to do so. If you want to learn more about Helm and customize, check out the links down below. Now, a common way to manage all these resources in Kubernetes, as I mentioned, is to use Kustomize or Helm templates. But there's nothing wrong with managing this YAML files in a Git repo and just using kubectl to deploy them. Generally, when deploying all these YAML files, you'd use the kubectl create command, but instead of imperatively creating each resource like we just did, we would pass in the -f flag and just point it to all the files. This will tell kubectl to deploy everything using YAML files. And if we make any changes to our infrastructure, we'd use the kubectl apply command and pass in the -f flag pointed to the YAML files, and Kubernetes will figure out the difference and apply the changes. So to use kubectl to apply changes, all we need to do is change our YAML files and then just say kubectl -n in the example apps namespace apply -f and the location of the YAML file or the folder. If I go ahead and run this, you can see it will go ahead and update all our resources, but it'll also print out a warning because we actually created all these resources imperatively. We didn't start with YAML files. So normally you wouldn't see this because you would start with the YAML files and run the kubectl create -f command to deploy the resources for the first time. And then you would use kubectl apply -f to apply any changes. You can see if I make any future changes and run the command again, we don't get those warnings. So Kubernetes will only roll out the changes if any changes are detected in the files. So if I want to roll a new version of Nginx of my application, I can go to the deployment YAML, I can change the image tag, so I can go to Nginx and change the tag of the image to some version, and then just run the apply command again, and that'll roll out new pods with the new version. Now, to show you the power of kubectl apply and the power of Kubernetes in general, I'm going to show you how to deploy a whole bunch of infrastructure with a single command. If you want to learn more about Kubernetes, check out my Kubernetes tutorial, which is a basic tutorial covering how to learn Kubernetes in 2022. This guide will walk through understanding containers, creating local networks, basically building a WordPress site with a database locally, and then moving all of that to Kubernetes and understanding each of the resources we've just worked on. And just to show you how much time Kubernetes saves, I can quickly deploy all that infrastructure with just a few commands. I can say kubectl create ns for namespace, and I'm going to create a namespace called WordPress site. I'm just going to deploy a quick WordPress site to Kubernetes, and all I need to do is in that namespace apply -f and apply my infrastructure infrastructure. So I have all this done in a previous tutorial. Go ahead and apply all that, and then what I can do is use the kubectl get service command. Go ahead and run that, and we can see we have a WordPress service and a MySQL service which backs our WordPress site. And then I can port forward to that WordPress service by running the port forward command we learned about earlier, and I can go to localhost and we see we now have a WordPress up and running backed by MySQL. So you can see how easy it is to just deploy a whole bunch of infrastructure using kubectl. And as I mentioned before, there are other tools to manage large amount of YAML files and package them together so they become easier to manage. So you can package all these YAML files up and call it a Helm chart like WordPress, or you can package them up as a customized package. Both Helm and Customize are templating engines, so it allows you to pass parameters in so you can make your YAML portable. Be sure to check out the link down below to my Helm and Customize tutorials. Now, to show you the beauty of Kind and managing Kubernetes clusters locally is once you're done, you can easily remove these clusters by saying kind delete cluster and give the name of the cluster. So I can just do that. That'll delete the dev cluster. I can do that, and that'll delete the prod cluster. And if I do docker ps, we can see those Docker containers are gone. You can also use the docker rm command to just remove the container. Very easy to spin clusters up and down. Now, I hope this video helped you break down that intimidating wall of learning Kubernetes for the first time, especially when using the command line. Now you can either take this a step further and learn how to build your first Helm chart or customized template, or you can watch my video and learn how to learn Kubernetes in 2022 and learn more about all the different Kubernetes resources like deployments, pods, stateful sets, secrets, ingresses, and more. And if you liked the video, be sure to like and subscribe and hit the bell. Now, if you want to support the channel even further, be sure to check out the link down below to the Patreon page, or click the join button down below and become a YouTube member, and let me know down in the comments what sort of videos you'd like to see in the future. And as always, thanks for watching, and until next time, peace.